Bismillahirrahmanirrahim. Welcome back. In previous tutorial, we learned how we can configure the Z specification in Eclipse, and we saw different the steps involved. Now, in this tutorial, we are going to make a small Z schema in Eclipse using the CZT plugin. So the example that I'm going to follow is the famous birthday book example, where we have different user IDs as names, and each user ID is linked with a birthday, and we have this partial function defined for the names that are mapped with this their respective birthdays. So now the thing we are going to learn is how we can define these sets and how we can define this schema in the Eclipse CZT. So here I open the Eclipse. I'll go to File, New, Project, and from the project I am going to select under this CZT category the CZT project. Next, and here I need to specify the name of the project. So for example, I am setting the name as my Z project. It would be good if we have more meaningful name. For example, we give it name as birthday book. So finish. Now currently this folder is empty. I'll click right click, new, and then I will click on this file, and here rather I will go to new. The first thing that I need to do here is so here I minimize the size, and first of all, the first thing that I must do after creating this new project is that I need to switch it to the Z perspective. So I need to click on this thing. This is the Z perspective, so I need to click on this one. So once I clicked on this one, now when I'll right click on this one and click on new, it's giving me different options like Z specification, CZT project, and all that. However, if it was not, this thing is not selected and only this thing is selected as it was previously, and when I click new, it's not giving me the option for the new Z specification. So I clicked on this one, and then if I click on this one, I can see the different mathematical characters that we normally use, mathematical symbols that we normally use in the Z specification when defining the Z specification. So here I click on new, and I click on Z specification. Here are three different options. I am selecting the Unicode encoded as UTF-16. Name is spec. You can change the name with any other name. For example, I change it to my spec, and I click on this finish button. So if this syntax is appearing, then this means that your Z is properly configured, and now we are good to go to write the Z specification code. So if we follow the example, the first thing we need to do is to define these two sets. The first one is the name, and the second one is the date. So for that we have this notation available type. So here I am declaring the name and date. So I declared these two types, and once I wrote this syntax, I can see that it is now available here, shown here. The next thing is I can also declare a set for messages. So for that I just need to press enter, and I can click on this thing, this symbol. The type name I am changing to message, and I can have different messages like OK message. I can define like already known, and similarly not known. So these are the message names of my own choice. So uh, so this is how we define the set of messages, and here it is shown on the right side of the screen. Now the next thing is the is declaring of the state space schema, and so how we can do that, we need to go to this this notation. So this is for the schema. So we need to just click once, because if we click multiple times, then it's going to show the multiple. So here we need to define these. We have the schema box. This is for the declaration, and this is for the predicates. So first of all, here we need to define the name of the schema that we have in this case as birthday book. Birthday book. And the next thing is declaration part. Here we have two declarations: known defined by power set of name, and birthday defined by the partial function of name to date. So known defined by the power set. So the power set is, we can see we need to find the notation of power set. So this is notation of power set. Known defined by, we need to just put the colon, defined by the power set of what? Name. So name is defined by the power set of, known is defined by power set of name. And then the next one is, we need to define the partial function, this one, and this one is birthday is defined by name to date. So we just need to write birthday is defined by the name of the two sets. The first one is name, and then we have this partial function notation here, and then we have this date. So these two variable declarations are now done, and now the next thing is we can write this invariant part. So known is equal to domain of birthday. We can write this: known is equal to domain of birthday. And since there is no error line, so this syntax is now okay. And we have this this schema now, state space schema is now showing here. So these variable names are exactly as we are defining here. For example, if I am defining known here, then I cannot have anything else here, like known one cannot be here, because otherwise it's going to show this error. So after we define this state space schema, we can quickly define the initial state schema, and again we have this birthday book, and known is equal to is initialized by 5. So the good thing about this is I can also use the comments here. So I wrote these are used for the comments, and for example, I am the definition of state space schema. Now I can go to the next one, the definition of initial state schema. And in order to define the initial state schema, I am going to use this same notation here, the name of the schema. So as we can see this in this example, it is init birthday book, so we can use the same birthday book. Then comes the declaration part, which is just the name of the system here. So we have the name of the system as birthday book, and then comes the predicate part, where we have known is initialized by, so known is initialized by the null set. So this is the null set already available here. So this is the so this is how we define initial, and then finally we are going to write one, for example, the schema, that is operational schema. So we can use this operational schema here, and this one is add birthday, add, or we can define insert new birthday record. So for this one we need a schema notation again, and this is going to give us that schema notation, and the name of the schema is add birthday. Then comes the declaration part, for example name, date. So we need to define two variables, name defined by name, date defined by date. These are the, and we can also define a message for the output, and its data type is message. So after these variable declarations, then comes the predicate part with precondition, postcondition. So precondition is name must be existing in this known set. So this means that if we have a name available, it must be related with a birthday, or its birthday record must be existing in the database. So we can write this condition here, name must be the member of known, and if this is true, then birthday, then we can have this birthday, and what is birthday? Birthday is the name of this this function. So birthday is equal to, here we can use the birthday is equal to, and we are going to store the updated value. So the notation that we are going to do is not a single quote notation. We are going to use the allowed notation, that is this prime quote is equal to birthday, and then we have union, or we can also use the override operator, for example this one, and name mapped with date. So we have this name, and we need this maplet notation date, and then the other thing that we can use is the message, and messages, for example we need to this and symbol, and msg is equal to, and what should be the message here? We have already defined different message types. So for example in this case we have this OK. So now we need to see if there are any issues here, then we need to resolve those issues. So we can see that there are still some issues here. We have these red underlines, so we need to resolve these issues. So let's review this schema. First of all, if you see that if name that is given as input belongs to known, then we are saying, then we have this implies that sign here, implies that birthday is equal. So this is technically wrong. The new name should be inserted only if this name is not present in the set of known. So first of all we need to change this symbol to not the element of, first one is this. The second thing is that we can also use this union here, but since it's the override operator, union override operations using the partial function, so we are going to use this operator. And now the error is still there, so we need to see what went wrong. So if you see, this is the schema name, and we are missing here the system name. So the system name was birthday book. So this was the system name. Now one error is gone, but still the other error is still there, because we are not telling here that what operation we are, whether this birthday book is modifying or not. So we need to since here it is modifying, we are changing the state variables. So here we need to specify this delta signature with this one, and now there is no error shown here. So this is how we perform this add birthday operation, and we can see that the different the state space schema, the initial state, and insert new birthday record using so these three, and we similarly we can define the other operation schemas here, like we have um, find birthday and all that. So we have the similar procedure for defining all these schemas. So after we are able to run this Z specification in Eclipse, then sometimes we may need to copy and paste this to our like word processor or something like Microsoft Word. So if I copy it, and if I go to the Microsoft Word, and if I copy and paste it over here, so we can see that here it is pasted, but sometimes we also need to, it is showing the Calibri font, and it is not showing the font that we in which we have written these mathematical expressions, and that font is the CZT font. So we can install the CZT font on a Windows 8 machine by following following these steps. First of all, we need to go to the control panel. In the control panel, we need to go to the option here. Um, uh, we need to select the option. We need to select the option appearance and personalization, and under this option we have this fonts, and then we go to font settings. Here it has hide fonts based on language settings. We need to check this for installation setting. To save space on your computer, you can choose to install a shortcut to a font file instead of the file itself. If the font file becomes unable, you might not be able to use the font. Allow fonts to be installed using a shortcut at once. So I am checking this option, and then click OK. Now here the next step is that I need to download the CZT font, and the link to that font is also available on this URL, from where we can download this font. And when I click this one, and here we have this option CZT font, and download the CZT Sans font. I can download it on for example on my desktop. Save. Then from desktop I clicked install. So now this CZT font is installed, and so it is installed. And now if I reopen my Microsoft Word, like I close this window and I again open Microsoft Word. So if I try to find out that font from the fonts menu, so we can see that this font is now available here. And now I can so if I open one of my previous examples that I've used in Eclipse. Suppose let's say I go to the directory of this um, file, and I want to see file open paste open. Let's see whether it opens or not. Could not open. So this was like the file of another project, so it's not opening, but it's totally fine. Even if we can just like copy, Control C, copy, and paste it here, Control V. So now this time when I am pasting here, this thing is pasted in CZT font, and it is looking more neat as when it was shown in the Calibri. So this is how we work uh, in we can define the specification in Eclipse, and we can configure the font on the Windows platform. Um, that's all about for the time being for this CZT configuration. Thank you for watching this video.